Hi, so welcome back everyone. Last time we did discuss how you could evaluate some integrals using trigonometric substitutions, and we emphasize that this identity sine squared theta plus cosine squared theta is equals to 1 is a very powerful one, and I want you to appreciate the beauty and simplicity of it and also the power. Okay, now if you look at this expression here, and you see that you can't do this directly, and this problem is very intimidating, especially when you don't know our little identity here, because this square root and then you have a fraction, like this is so intimidating, especially for beginners in calculus, but it's actually easy to work out. And the way to do this is that, like I said last time, always try to like put this in this form: 1 minus sine squared theta, 1 minus sine squared theta is equals to cosecant squared theta. And then when you make your observation, you see that if assuming sine squared theta is here, so you have a square root of 1 minus sine squared theta, this will be the square root of cosine squared theta, which will be, so this means that you can eliminate this square root, because we all know that the square root of cosine squared theta is basically cosine theta. So that means you could eliminate this square root and you have a simpler expression. Although this does not solve the problem, but it does take off some burden from your neck. So what we are going to do here is that we're going to consider this integral, which is square root of 1 minus x squared all divided by x squared dx. And then we're going to let x to be sine theta, because we badly need to get sine squared theta inside this square root. So that is why we're going to let x to be sine theta. Then from here, we're going to look at dx. This will be cosine theta d theta. So if you come to this integral, this will be the integral of, instead of 1 minus x squared, we have a square root of 1 minus sine squared theta. And instead of just x squared, we don't have a sine squared theta, and then dx. So dx, it becomes cos theta d theta. Of course, many of you argue that, okay, but we already made it complicated. Yeah, it may seem, but we are going to simplify it. So because square root of 1 minus sine squared theta is basically, this is the integral of just square root of cosine squared theta, which is cos theta. So you have cos theta all divided by sine squared theta. Then you have cos theta d theta, and then this will become the integral of cosine squared theta all divided by sine squared theta d theta, which is basically the integral of cotangent. And this integral of cotangent squared theta d theta here, I'll do it on this part of the screen. So let's see. So we have this integral of cotangent squared theta. The way we evaluate this integral is that, notice that since sine squared theta plus cosine squared theta is equals to 1, then you can divide by sine squared. If you divide by sine squared, you have 1 plus cotangent squared theta is equals to cosecant squared theta, which means that cotangent squared theta is equals to cosecant squared theta minus 1. So this integral here will be equal to the integral of cotangent squared theta d theta would be equal to the integral of cosecant squared theta minus 1 d theta. And this is not too difficult to look at, because we know that the integral of cosecant squared theta is negative cotangent theta. So, and also the integral of negative 1 is theta. So this is a negative cotangent theta minus theta plus c, and that is all. So this integral here, this integral of square root of 1 minus x squared all divided by x squared dx is equals to negative cotangent theta minus theta plus c, where x is equal to sine theta. So that means theta would be sine inverse of x. So if you plug in theta, so you get theta here equals sine inverse of x. But this whole integral has been solved, and all thanks to our powerful trig substitution. So thank you for watching, and please subscribe to the channel.